We're given a point in Cartesian coordinates and asked to find possible cylindrical coordinates. So the given point has coordinates 4, negative 3, negative 5. So we know x equals 4, y equals negative 3, and z equals negative 5. To find possible cylindrical coordinates, we need to find r, theta, z, but we are asked to use positive values for r and theta and also to round to 2 decimal places if needed. So to find r, theta, and z, we'll use our formulas here below, but for a quick review, r, theta is the polar representation of a point in the xy plane, where r is the directed distance from the origin in the xy plane, this distance here. Theta is the angle counterclockwise from the polar axis or positive x-axis in the xy plane pictured here. And finally, z is the directed distance up or down from r, theta to the point, which would be this directed distance here. So going back to our example, so we can better visualize this, let's plot the point 4, negative 3 in the xy plane. So this would be the x-axis, this would be the y-axis. And since the x-coordinate is positive 4, we'd go right 4 units. And because the y-coordinate is negative 3, we go down 3 units. So this would be the point 4, negative 3 in the xy plane. And therefore this distance here would be r. And then angle theta would be any angle that terminates along this side. But since we're looking for a positive value for theta, the least positive value for angle theta would be this angle here. Notice how if we wanted to, we could also sketch a reference triangle, which would look like this, where this would be labeled 4 and this would be labeled negative 3. So notice how to find r would just be using the Pythagorean theorem given here as r squared equals x squared plus y squared. Let's begin by determining r. We know r squared is equal to x squared or 4 squared plus y squared, which is negative 3 squared. So we have r squared is equal to 16 plus 9. So r squared is equal to 25. And then we'll take the square root of both sides of the equation. Notice here we'll have two solutions for r equals plus or minus 5. We are asked to use a positive value for r though, so we'll use r equals 5. Remember, if we use a negative value for r, then we'd plot the point in the xy plane in the opposite direction of our angle theta. Next, to find theta, we'll use the equation tangent theta equals y divided by x. So we have tangent theta is equal to y divided by x would be negative 3 divided by 4, or negative 3/4. And now to solve for angle theta, we would take the inverse tangent or arctangent of both sides of the equation. So theta is equal to inverse tangent of negative 3/4. Here we might recognize that the output of the inverse tangent function is on the open interval from negative pi over 2 to positive pi over 2. So the calculator is not going to give us the angle theta that we're looking for, but we can still use the calculator to find this angle. Let's first verify that we are in radian mode. So we'll press the mode key. Radian is highlighted, so we'll go back to the home screen. Press second tangent, negative 3 divided by 4, close parenthesis, and enter. So notice how the calculator is giving us an angle that terminates here, but it's a negative angle. This would be approximately negative 0.64 radians. Let's go ahead and sketch this. The calculator gave us this angle here. Our angle is coterminal to this, and therefore we can take this angle here and add 2 pi radians to find the least positive angle for angle theta. And since we already have this value in the calculator, we can press plus 2 pi, enter. So the angle theta pictured here in red would be approximately 5.64 radians. So again, the calculator gave us theta was approximately negative 0.64 radians. But to find the least positive value for angle theta, we added 2 pi radians to find our angle, which is approximately 5.64 radians. So that's our second coordinate. The third coordinate is the z-coordinate, which is the same as the z-coordinate of the Cartesian point. So z is equal to negative 5. So here's one possible way to express the given point using cylindrical coordinates. I hope you found this helpful.